Okay, I wanted to run through just how to do your assignment, your classwork assignment. When you click on the link, here's what it's going to look like. And there's two things. And this is in the pack. So if you have your packet, some notes are in there and some problems to help you out. Basically, this is what it is. There's two different types of questions. This says determine the equation of the line that passes through the indicated point, which in this case is -123. And it's parallel. That's the key. We need to check and see if it says parallel or if it says perpendicular. So I'm going to do one of these to let you see what it looks like. So this may not be yours. This is just one of the ones that may pop up. So here's what you need to do. First thing, it says determine the equation line indicated through the points parallel. That's the first thing I need to recognize. This says parallel. Okay, parallel, y'all know what parallel is. It's, two lines, they never touch, they keep going. But now that we're doing it in an equation, we've got to know this. Parallel lines have the same slope. Well, if you go back, and we've already talked about this in class, but we need to talk about it. This is in y equals mx plus b form. All right, and part of the assignment is for you to write notes. So you need to do that. I'm going to give you 4 problems. You need to write notes on all 4 of them. Take a picture of it and attach it. So y equals mx plus b, I've known that for quite some time. The m is the slope. So here's the question. This is going to be a line, and if you want to graph it, we talked about how to graph it. You can graph that. You go to the Y-Intercept, put a point at 12, use the slope, right? M is slope, rise 1, run 5. So for this equation that I'm going to type right here, it's got to start with y equals 1/5 x, because that 1/5 tells you what the slope of that original line is right here. And if it's parallel, it has to have the same slope. So this equation has to start with this. If you want to go ahead, each question that says parallel, you can go ahead and type that in, the first thing. Now what we got to figure out is instead of plus 12, what is this thing? So what is the y-intercept? And that's where these points come in. Okay, so I know parallel, same slope. I know it starts with that. So here's the next thing. This is a shortcut. Now you could graph it, it just takes some time. There's a thing called the point slope form, and it is this. Okay, so this is slope intercept form, right? You have to have the slope and the y-intercept. Point slope form means I have to have a point, which in this case is -5, -1, and I need to know the slope, which because this is parallel, I know that's 1/5. So your y minus y1 m, which is slope, x minus x1. So this x1, y1, that should be familiar because that's how we label these points. Y is going to be y, x is going to be x. Okay, so we're going to label this. -5 is x1, and it's going to go right here. -1 is y1, and I'm just going to plug that in. I'm going to substitute that in. So y minus y1, well, if y1 is -1 minus, I'm going to go ahead and write it like this so you know we have plugged in a -1. All right, but minus a negative, that's actually going to be plus a positive. So that's actually going to turn into this. So if you want to skip this step, you can. But y minus y1, y1 being -1. So equals m, which is the slope we knew was 1/5. That's just by looking at it. All right, and then x minus x1. Well, x is x minus x1. x1 is -5. So I'm going to write it the same way I did that -1. But again, that minus a negative means plus a positive. So if I wanted to kind of, you could actually skip down to this step. If you know minus a negative is plus a positive. So this is what I get. Now here's the key. I got to make this look like slope-intercept form. So I've got to get y by itself. So go back to your order of operations, right? Parentheses, that means multiply. So I'm going to distribute that out. So negative 1/5 x, that's, or 1/5 x, excuse me, 1/5 x. 1/5 times 5, that is 1. And use your calculator if you're not very comfortable with fractions. And then I have the left side. Okay, this one's a little different, but the way you get y by itself, right, y equals mx plus b, is I gotta get rid of this plus 1. I say get rid of it, you're just moving it over here. Cancels that. Now this is kind of unusual, but I have my 1/5 x. And 1 minus 1 is 0. I'm not going to put plus 0. This is my answer. So if what you're about to do, you come across this question, you're just going to put y equals 1/5 x. Now here's a way to check it. I advise you to do this every time. If x is -5 and y is -1, it's got to fit this equation that I just made. So 1/5 if x is -5. So 1/5 of -5, that's -1. And just substitute it in. So y should be -1, and it is. So, but it's got to fit. So if I go back to my question, here's how I type it in. I'm sorry, that's a different question. All right, we'll do that one. So that's how you do one of those. All right, let's do another parallel one. All right, this is the one, right? 16 and 5, -1/4 x. All right, so we'll do this one. All right, so if I have this, again, your first question is, what am I dealing with? Well, I'm dealing with parallel again. So that tells me same slope. So I know it starts with -1/4 x. So I know my equation, whatever I'm going to type in here, is going to start with this because of the y equals mx plus b, and that m is the slope. I know it's going to start with that. Now, this plus minus is just a minus 19. I don't know why they do that, but that's just minus 19. But unless I'm going to graph it, I really don't even need this unless I'm going to graph it. Okay, the only reason I need this equation is to figure out this slope. And because it's parallel, we're here. So now we got x1, y1, putting it in the point slope form. So y minus y1, which is 5. M, because we're dealing with parallel, is -1/4. I mean, you can see this is a lot quicker than graphing. Minus x1, which is 16. And you solve that in slope-intercept, not solve it, simplify it into slope-intercept form. All right, distribute. Hopefully when you write this, it's neater than, right, -1/4 times -16. If you need to put it in calculator, put it in calculator, but that is going to be +4. Right, negative times a negative. And then I got my -5 over here. To get y equals mx plus b, I add 5. So this is the same steps every time. So if you write this down, you're going to follow the same steps every time. You're just going to have different numbers. All right, that cancels. That's why we did that. So answer would be -1/4 x. And 4 plus 5, that would be 9. So I'm going kind of quick, but this is a video that you can pause and go back and rewrite if you need to. But this would be the line parallel to my original and running through 16.5. Now if I put 16 in for x, I'm going to get 5 for y. And that tells you that that point is on that line. All right, so that's how we're going to do a parallel question. All right, the next one. Still using point slope. All right, and we'll do one let's go back to the website here. All right, that one says parallel. That one says parallel. All right, this one says perpendicular. Let me find one that is a little better. All right, this is a perpendicular one. So I'm going to copy and paste this, and I'm going to work this one for you. And perpendicular is a little different. This is the one that kind of gives people problems. But I'm going to work it for you, and hopefully, again, this is a video, so you can go back, watch it, slow it down, whatever. But every problem is going to be worked the same way. Every perpendicular problem can be worked the same way. It's just going to have different numbers. So we're going to work this problem right here. Now, the thing about perpendicular, and it's on your worksheet, your packet, stuff I gave you. Okay, let's slow down and talk about this. Perpendicular lines have slopes that are negative reciprocals. That's what the book is going to tell you. Our interactive reader, it actually says something different. It says it has to multiply to get -1. So if I take the slope of the original, which is -1/3, and I multiply the slope of the new one, the book says that has to be -1. It's also called negative reciprocals. The way I would like to remember, probably better for you to remember, is flip and change sign of the original slope. So this is already in slope-intercept form. Right? We'll get to next week. This will not be in slope-intercept form. We'll have to figure that out. But this is. So you have to recognize perpendicular. Perpendicular tells you this. So if the original slope is -1/3, to get the slope of the perpendicular, okay, and when I get back to school, I'll show you on a graph what it kind of looks like. Because I see perpendicular, I'm going to flip this, so 1/3 turns into 3/1, and change the sign. So now, because it's perpendicular, this has to start with 3x. Because I flipped it, made it 3/1, and I changed the sign, so that negative turns into a positive. So now this 3 is going to be my m, because we're dealing with perpendicular. And then your x1 and your y1 are the same as it was in the parallel question. So y1 is -1, so minus a -1, I'm going to go ahead and put +1, right? Minus a negative plus a positive. 3, and then x minus x1. x1 is -2, so minus a -2, I'm going to go ahead and put +2. Right? Just like the other one, where it had minus a negative. And then you distribute. If you recognize, this is the same steps as before. Right, that's 3x, which we knew it was going to start with 3x, because we flipped and changed the sign. That's a +6, right? Distributing, we're multiplying. And to get y by itself, because of the slope-intercept form, we subtract 1. That cancels, that's 0. 3x, and then I got 6 minus 1, that would be 5. So that is the equation that is perpendicular to the original and runs through -2, -1. So to check it, put in -2 for x, right? 3 times -2, -6, plus 5 is -1, and that fits. So 3x plus 5. So if I go here, what you're going to put in is y equals 3x plus 5. It says yes or no. So what you need is, when you do this, you need to find 2 perpendiculars and 2 parallels. Right? This was a perpendicular question. Here's another perpendicular question. So again, that's the first thing you need to recognize. Am I doing perpendicular or am I doing parallel? Parallel, this is going to start with y equals -3/4x. perpendicular. All right, we'll go ahead and do this. I'm going to flip that and change the sign. So I know that it's going to start with y equals, I'm going to flip that, that's 4/3, change that negative to positive. So I know it's going to start with that. And then I use my point slope to find out what the rest of it is, the b. Okay, let's do this one. Again, all these 4 we're going to do need to be in notes. The assignment's going to tell you to write the notes, take a picture of it, and then attach it to the assignment. So you need to do that. So these are the 4 that everybody should have. We already did 2 parallels. We did 1 perpendicular, and here's the next perpendicular. Okay. Now again, perpendicular lines. Slopes that have negative reciprocals flip change signs. So again, I recognize first thing, this is perpendicular. I'm going to go ahead and start because we've already talked about this. Flip it, change the sign. So that is 4/3. And this is the way it's going to look when you type it in, 4/3 x. And then you go ahead and type that in. And then on the side, I'm going to work point slope form, which is y minus y1, m, which is, that's an m, 4/3 x, or 4/3. Right? M is just the number. X minus x1. That is the point slope form. Now, how do I know when I use it? When I have a point and I know the slope. So again, x1, y1. Right. Minus y1, that's minus a negative, so that's plus a positive 13. M, 4/3. And x is x minus x1, and x1's a -3. So that's going to be positive 3 minus a negative plus a positive. So you see it's going to be the same steps. After I get it set up, right, substitute it in, I'm going to distribute my m, which again, we knew it started with 4/3 x. And we've already got that in here. 4/3 times 3. That is 4. Now, if you need a calculator, then do calculator. I'm hoping, well, just quick review on multiplying fractions. 4/3 times 3, that's 3/1. And multiplying, you just multiply straight across. So that's 12/3. And 12/3 is 4. Or, you know, back in the day, if you took this, they talked about you can cross cancel, right? 3's cancel, right? And you just get 4. So just quickly review on fractions. But after I get this, subtract 13. Again, we got some negatives, so be careful. So 4/3 x, 4 minus 13, that is -9. All right, and then if I plug in -3 for x, I should get -13 for y, and you do. So this is 4/3 x minus 9. All right, we'll go back to the site. 4/3 x minus 9. If that's right. We're good. So your assignment is to do 2 parallels on this site and 2 perpendiculars. Now you may have to, like if I've already done a parallel and go to the next one. All right, that says parallel. That's the 3rd parallel. So I may have to click new problem a couple of times to find 2 of them. And if you want to, like if I get to this one and it's like, I don't, that's like too big a number, or you don't, whatever, then I don't care. Just find like those negatives like freak you out or whatever. Just find another one. Okay. So find 2 that are parallel, 2 that are perpendicular, write them down and solve them. All right, and once you solve them, go ahead and put them in here because I'm going to see which ones you do. I'm going to see how you do because y'all have already in. Once you log in, once you click on that site, that link, it's going to show me what you do. All right, so any questions on that? Email me, message me somehow during class, and then we'll go with that then. All right, see y'all.